This is now the part 15 of the LEED V4 Reference Guide for Homes Design and Construction online review. Again, all the pictures or images in this video are from Google and USGBC website. If you have comments, suggestions, or complaints regarding the images, pictures, or in this video itself, please email me at nelka_rocco@yahoo.com and I will immediately reply to you and take action on whatever the reason of your email. Thank you. Why I created this online reviewer? To help myself and others to pass the LEED AB exam in one shot. These are the LEED credit categories. On my previous video, we discussed the water efficiency prerequisite 1, the water meter. Now, we will proceed to water efficiency credit 1 under the performance path, the total water use. Total water use is the first credit of water efficiency under the performance path. It has a possible of 12 points and 1 exemplary performance. Total water use intent to reduce demand for water through high efficiency fixtures and efficient landscaping practices. It is possible for 12 points under the performance path. Requirements: reduce total indoor and outdoor water consumption by at least 10% over standard practices. For indoor water savings, use the water reduction calculator to determine the average flush or flow rate for each fixture type and the estimated daily usage. The baselines for indoor water consumption are shown in Table 1. Table 1. Indoor water baseline consumption per person per day. Fixture, shower, per compartment. Baseline flush or flow rate is 9.5 liters per minute. Estimated fixture usage, 6.15 minutes. Estimated water usage is 58.4 liters. Lavatory and kitchen faucet. Baseline flush or flow rate, 8.3 liters per minute. Estimated fixture usage is 5 minutes. Estimated water usage is 41.5 liters. Toilet. Baseline flush or flow rate is 6 liters per flush. Estimated fixture usage is 5.05 flushes. Estimated water usage is 30.3 liters. Clothes washer. Baseline flush or flow rate is 9.5 water factor. Estimated fixture usage is 0.37 cycles at 3.5 square foot or at 0.1 per square meter. Estimated water usage is 57.1 liters. Dishwasher. Baseline flush or flow rate is 24 liters per cycle. Estimated fixture usage is 0.1 cycles. Estimated water usage is 2.4 liters. Further to requirements, the water pressure in single-family buildings must not exceed 60 psi or 415 kPa, with no detectable water leaks. Any installed water softeners must be demand-initiated. For outdoor water savings, use the EPA WaterSense water budget tool to calculate the baseline landscape water consumption and the design landscape water consumption. Implement the following measures to further reduce landscape water consumption. Add the savings associated with each of the following strategies to the reduction from the landscape water requirement, as calculated in the water budget tool. 1. Install smart scheduling technology. This strategy counts for a maximum reduction of 30% provided all landscape water use is controlled by a soil moisture sensor control system or a weather-based irrigation control system. 2. Use captured rainwater. 3. Use reclaimed water. And 4. Use water treated on-site or conveyed by a public agency specifically for non-potable uses. Water from naturally occurring surface water bodies such as streams and rivers and groundwater such as well water does not count. Points are awarded according to Table 2. Table 2. Points for reducing indoor and outdoor water use. Percentage reduction: 10%, 1 point; 15%, 2 points; 20%, 3 points; 25%, 4 points; 30%, 5 points; 35%, 6 points; 40%, 7 points; 45%, 8 points; 50%, 9 points; 55% 10 points, 60% 11 points, and 65% for 12 points. Projects attempting this credit are not eligible to earn points under other water efficiency credits. See in this figure. Behind the intent, approximately 4 billion gallons of water is consumed in U.S. homes for indoor and outdoor water purposes every day. Landscape irrigation uses large quantities of potable water, accounting for 30% of non-agricultural use. Better landscaping can dramatically reduce and even eliminate the need for irrigation. Planting native and adapted species instead of turf grass, conventional monocultural lawns, can reduce maintenance, runoff, and fertilizer and pesticide applications. This credit rewards the use of native and adapted drought-resistant plants and the limited use of turf grass. Faucets, showers, baths, and toilets typically account for 2/3 of a home's indoor water use and 1/3 of its total water use. Installing low-flow fixtures and fittings can reduce water consumption without sacrificing comfort and performance. The most efficient fixtures and fittings use less than half the water of conventional alternatives. High-efficiency fixtures and fittings can also significantly reduce the energy demand associated with domestic water heating. In addition, project teams should be mindful of appropriate water pressure and monitor for potential leaks. Indoor water use in a LEED home is compared with the average behavior in the U.S. using the water reduction calculator provided by USGBC. Outdoor water use is calculated for a peak watering month using the WaterSense water budget tool of the Environmental Protection Agency or EPA. This credit is based on total water saved. Project teams should develop a combination of interior and exterior strategies, which may include water-efficient fixtures, low water use landscaping, and water reuse. Projects with outdoor water consumption that is estimated to be higher than indoor water use should focus on landscape water savings. Projects with small landscapes or large numbers of occupants will likely emphasize indoor water consumption. It is based on the U.S. Geological Survey estimated use of water in the United States in 2005, 2010 to be published by 2014. Step-by-step guidance. Steps in this section address general practices. Individual sections addressing each component of the credit requirements then follow in further explanation. Step 1. Plan water usage strategies. During the planning stage, complete the indoor and outdoor water calculators to approximate the water usage of indoor fixtures and landscaping. This will compare the project's water use with that of the average American household in Table 1 and indicate whether indoor or outdoor consumption is predicted to use more water. Prioritize the end use, indoor or outdoor, that is calculated to use more water while not neglecting the other. Consider the number of occupants and their behavior during the design phase. See further explanation occupants. Design the house for reduced consumption through efficient fixtures and fittings before considering alternative sources of supply. Example, rainwater or gray water. This approach, like that of reducing energy consumption, first efficiency, then renewables, avoids the overuse of alternative sources. Step 2. Install water-saving fixtures, fittings, and landscaping. Install fixtures and fittings, landscaping, and other items, example, rainwater collection system or irrigation system, that will conserve water. Test the water pressure and test the water system for leaks for at least 30 minutes. Step 3. Calculate indoor and outdoor water usage. Complete the indoor and outdoor water calculations based on the installed measures. For outdoor water, use the EPA WaterSense water budget tool, and then include results in the water reduction calculator. For indoor water use the water reduction calculator. We will now proceed to further explanation. Outdoor water use. EPA's WaterSense water budget tool may indicate that the non-irrigated zone will use 0 gallons of water. If this is the case, where landscaping includes both irrigated and unirrigated areas, do the calculation for both. No zone may be included that is estimated to use 0 gallons of water, so exclude areas that will not use water, such as permeable hardscapes. Enter LEED project as the use for the calculator and provide the project-specific information. For landscape area, include only vegetated areas, exclude all hardscapes, permeable or non-permeable, and non-vegetated softscapes. Keep a list of installed plant species for any landscape area that is estimated as having low water usage. See Figure 1, EPA WaterSense Water Budget Tool Report for outer water usage. This image is a screenshot from the Environmental Protection Agency website. Indoor water use. High-efficiency fixtures and fittings are becoming commonplace and are generally sold side by side with conventional items. From the consumer standpoint, they generally look and operate the same way as conventional fixtures and fittings, but use less water and have a lower rated water use in gallons or liters per minute or gallons liters per flush for toilets. Choose low-flow fixtures. WaterSense fixtures are tested for quality of performance in addition to quantity of flow. Low-flow aerators can be installed in most conventional faucets. Faucets and shower heads. Low-flow faucets achieve savings through the use of aerators, which combine air with water to give the user the feeling of an equivalent water pressure but with less water. Flow restrictors, which limit the amount of flow in a tap, are an acceptable strategy to earn this credit, provided the flow restrictors are hardware that cannot easily be removed. Low-flow shower heads, especially those with flow volumes of less than 1.75 gallons per minute or 6.6 liters per minute, should be installed with thermostatic mixing valves that have been designed, tested, and verified to function safely at the reduced flow rate. The use of conventional or compensating shower valves can increase the risk of scalding when the plumbing system experiences pressure changes. Consult shower head manufacturers' information for the performance of high-efficiency and very high-efficiency shower heads before making a selection. Low-flow shower heads and faucets will reduce both the hot water consumption and the rate at which hot water reaches the fixtures. If low-flow shower heads and faucets are installed, a smaller water heater and smaller diameter piping can be used. Toilets. High-efficiency toilets, or HETS, have an average or effective flush volume of 1.28 gallons or 4.8 liters or less. HETS generally use improved hydraulic designs, improved technologies, better valving, and in some cases smaller tanks. Some HET designs include multiple flush settings or pressure assistance to reduce water demand. For example, dual flush toilets have a normal flush rate for solid waste but a much reduced flush rate for liquid waste. See further explanation calculations. Pressure assist toilets achieve the highest water efficiency by using pressure rather than gravity to remove the waste. Flush valve conversion devices and toilet tank bags cannot be used to earn credit under WE credit total water use. Not all HETS operate equally well, and poor design can necessitate multiple flushes, defeating the purpose. Purchase toilets that have achieved WaterSense certification, signifying that they have met both water efficiency criteria and performance testing. Dual flush calculations. For this credit, the flow rate of dual flush toilets is calculated using the following formula, based on verified high and low volumes. Average volume is equals to high minus volume flush plus 2 times low volume flush divided by 3. Dual flush toilets can also be used to meet WE credit indoor water use if the average flow rate for all toilets in the home is 1.10 GPF or 4.16 LPF or less. If the high and low volume can't be verified, use the value of 1.25 gallons per flush or 4.73 liters per flush. Average flow rates of toilets must be calculated to the hundredths decimal place. For example, an average flow rate of 1.13 can be rounded down to 1.10. The calculation is embedded in the water reduction calculator. If the home will use any gray water or recycled water indoors, consider its quality when selecting fixtures. Determine whether the toilet manufacturer has set minimum standards for supply water quality. If rainwater or grey water will be used with plumbing fixtures and fittings designed for municipality-supplied potable water, determine whether the use of grey water will affect the manufacturer's warranty. Water pressure. The flow rate of plumbing fixtures is measured at 60 pounds per square inch or PSI or 415 kPa. When house water supply pressures varies, fixture flow rate drops or rises with it. This credit requires a maximum static service pressure of 60 psi or 415 kPa for single-family homes or multi-family mid-rise, see below. However, installing pressure regulation valves to ensure correct water pressure is encouraged in multi-family buildings. Pressure regulation valves should be installed on the house side of the water meter to regulate water flow to the fixtures. For example, a reduction in pressure from 100 psi to 50 psi at an outlet can reduce water flow by about one-third. A pressure gauge can be screwed directly into a hose bib to measure the psi of the home's water flow. Water pressure over 60 psi or 415 kPa can void manufacturer's warranties for plumbing fixtures. Many residential plumbing fixtures are engineered to pressures no greater than 75 to 80 psi or 520 to 550 kPa. Pressures such as tanked water heaters, dishwashers, refrigerators, ice makers, and pressure assist toilets can leak to have shorter lifespans if pressures exceed the rated maximum. Conversely, low water pressures lengthen usage times and cause annoyance. Have the water pressure tested by a plumber or rater. Figure 2. In single-family homes, if the supply water pressure is more than 60 psi or 415 kPa, reduce the flow. Appropriately regulating water supply pressure also reduces the leakage rate. Leaks. Water leaks account for, on average, 20% or more of indoor water use. Projects must be free from detectable water leaks. Test for water leaks using a pressure gauge. Turn off all water fixtures and fittings in the home. Install a pressure gauge on a hose bib and check pressure in PSI. Do not turn on any water using the testing period. If pressure is unchanged over a period of at least 30 minutes, there is no detectable water leak. If possible, also check for leaks between the utility meter and the building by turning off all water fixtures and fittings. If the meter reading is unchanged over a period of at least 30 minutes, there is no detectable water leak. Figure 4. Water pressure and leak testing performed at exterior hose bib. Photograph by Asa Foss. Occupants. The number of occupants and their individual water use habits greatly affect water consumption and energy savings. Assume 2 occupants for a studio or 1-bedroom residential unit and 1 additional occupant for each additional bedroom. Occupants are encouraged to share energy usage data with USGBC via a USGBC-approved third party. Include information about the benefits of participation in the Operations and Maintenance Manual. EPA WaterSense. A voluntary partnership program sponsored by the EPA. WaterSense seeks to protect the nation's water supply by promoting water-efficient products and services across the country. The WaterSense label identifies high-efficiency products that have been verified for performance. The EPA WaterSense program certifies toilets that achieve both water efficiency and operational effectiveness. The WaterSense label identifies high-efficiency products that have been verified for performance. WaterSense currently labels high-performing, water-efficient toilets, bathroom faucets, urinals, shower heads, and weather-based irrigation controllers, as well as a certification program for irrigation professionals. Specifications for water softeners and pre-rinse spray valves are under development. Multi-family mid-rise. Multi-family projects are exempt from the maximum water pressure requirement because of services with higher PSI requirements. All the other requirements of this credit must be met by multi-family projects in both residential and non-residential spaces. Related credit tips. WE credit indoor water use. This is the prescriptive pathway for indoor water consumption. The project cannot pursue both total water use and indoor water use. All projects are encouraged to use total water use, but teams with some multi-billion projects may find it easier to plan with the indoor water use credit. WE credit outdoor water use. This is the prescriptive pathway for outdoor water consumption. The project cannot pursue both total water use and outdoor water use. all projects are encouraged to use the total water use, but teams with some multi-building projects may find it easier to plan with the outdoor water use credit. EA Credit Efficient Hot Water Distribution System. Low-flow fixtures increase the time it takes hot water to reach the tap because less water is flowing through fixture at any point in time. Efficient hot water plumbing is therefore especially important for buildings with low-flow fixtures. Changes from LEED for Homes 2008. This is a new credit. Contract language recommendations. Plumber. Install plumbing fixtures that are WaterSense certified and or meet the required flow requirements. Plumber again. Install a pressure regulation valve or PRV. Test the system after work is complete to determine the supply flow pressure. Adjust the valve as necessary to ensure flow below 60 psi or 415 kPa for single-family homes. Test the entire water supply system downstream from the utility installed meter for water leaks for a minimum of 30 minutes. Repair any leaks that are detected. Landscaper. Do not install plants listed as invasive by the local cooperative extension service or other reputable resource. Choose and install only regionally native adapted and or drought-tolerant plants and provide documentation. Technical resources. Pressure Reducing Valves Save Water and Prevent Problems by Peter Yost, Green Building Advisor 2010. His website is greenbuildingadvisor.com/blogs/depth/water/pressure reducing valves save water and prevent problems. Maximum Performance or MAPTM testing, California Urban Water Conservation Council. The website is cuwcc.org/maptesting.lasso. Product News, California Urban Water Conservation Council. Their website is cuwcc.org/products_tech.lasso. Terry Love's Consumer Toilet Reports. Their website is terryLove.com/crtoilet.htm. Water Use It Wisely. Their website is waterusitwisely.com. Water Wiser, the Water Efficiency Clearinghouse. Their website is awwa.org/waterwiser. Reference Standards, Energy Star, and WaterSense Water Budget Tool. Exemplary Performance. Projects that achieve savings of at least 70% earn 1 additional point. Verification and Submittals. Supporting verification materials made available by the project team. Complete Water Calculator. List all fixtures, clothes washers, and dishwashers. Complete WaterSense Water Budget Tool and provide list of plants and landscape plan. If using captured rainwater, provide sizing calculation and product details. If using high-efficiency irrigation or smart scheduling technology, provide product details. Group Project. Outdoor water calculation using WaterSense Water Budget Tool can be averaged for multiple single-family homes only if entire development is owned by one organization or all landscaping is managed collectively and landscaping is similar for all homes. Otherwise, calculation must be performed for each lot. Verification Team. Visually verify that listed indoor fixtures were installed and that water calculator's inputs match installed fixtures' performance criteria. Test water pressure in single-family homes and record pressure. Test for water leaks. Conduct on-site verification that outdoor water use calculators' inputs match installed fixtures' performance criteria. Conduct on-site verification of any water-saving items identified in calculation, including high-efficiency irrigation measures and high-low shading conditions. For any drought-tolerant plants, compare list of installed plants with list of regional drought tolerance plants created by a third-party entity, example Cooperative Extension Service. Glossary. Potable water. Water that meets or exceeds U.S. Environmental Protection Agency drinking water quality standards or a local equivalent outside the U.S. and is approved for human consumption by the state or local authorities having jurisdiction. It may be supplied from wells or municipal water systems. Peak watering month. The month with the greatest deficit between evapotranspiration and rainfall. This is the month when the plants in the site's region potentially require the most supplemental water, typically a midsummer month. Sustainable Sites Initiative. Water budget. A project-specific method of calculating the amount of water required by the building and associated grounds. The budget takes into account indoor, outdoor, process and makeup water demands and any on-site supply including estimated rainfall. Water budgets must be associated with a specified amount of time, such as a week, month, or year, and a quantity of water such as kgal or liters. Reuse. The reemployment of materials in the same or a related capacity as their original application, thus extending the lifetime of materials that would otherwise be discarded. Reuse includes the recovery and reemployment of materials recovered from existing building or construction sites, also known as salvage. Gray water, untreated household wastewater which has not come into contact with toilet waste. Gray water includes used water from bathtubs, showers, bathroom wash basins, and water from clothes washers and laundry tubs. It must not include wastewater from kitchen sinks or dishwashers. Uniform Plumbing Code Appendix G, Gray water systems for single-family dwellings. Wastewater discharges from lavatories, bathtubs, showers, clothes washers, and laundry sinks. International Plumbing Code Appendix C, Gray water recycling systems. Some states and local authorities allow kitchen sink wastewater to be included in gray water. Other differences can likely be found in state and local codes. Project teams should comply with the gray water definition established by the authority having jurisdiction in the project area. This is the end of this video. Thank you for watching. Watch for the next video, LEED V for Homes, Water Efficiency, Credit to Indoor Water Use. See you again later.